Heat pump installations are booming, which is great news for electricians and, dare I say it, plumbers. But even if you don't install heat pumps, this is something you need to understand, because this isn't just about the heat pump itself, it's about anything electrical you install nearby. EV chargers, outdoor sockets, garden lighting, put them in the wrong place and you could be creating the conditions for an explosion. And the scary part is, everything you've installed could be working perfectly. It's the location that turns it into a risk. So what's changed? It comes down to what's inside modern heat pumps. For years, a lot of systems used R32. That's the refrigerant, the working gas inside the heat pump that actually carries the heat. No refrigerant, no heat pump. It's efficient and common. But one of the big reasons manufacturers are switching is GWP, global warming potential. And GWP is basically a simple score for how much warming impact a gas has if it escapes into the atmosphere compared to CO2. CO2 is 1, R32 is 771. So manufacturers are increasingly moving to a refrigerant called R290 because its GWP is dramatically lower. R290 is 0.02. That's a massive step down in impact if there's ever a leak. And there's another advantage that matters in the UK. R290 systems can support higher flow temperatures, which can be a real help in older homes with traditional radiators. Brilliant, until you realize R290 has another name, propane. Yes, the same stuff you run a camping stove or barbecue on. Under normal conditions, it's sealed safely inside the system. No issue. The risk is if there's a leak. Propane is heavier than air, so it can drop, spread, and linger low down around the unit, especially in dips, channels, and below ground areas like light wells or basements. Now look at the manufacturer visuals on screen. This protective zone they're defining is basically a zone 2 hazardous area, the kind of thinking you see at petrol filling stations, chemical plants, flour mills, anywhere a flammable atmosphere could exist briefly under fault conditions. And the rule is simple: no ignition sources inside that zone, which includes an isolator, because switching can create an arc. So if gas is lingering low down and you walk up and do the sensible thing, isolate the unit, that normal little arc becomes sparks, and boom. So you've got two options. Option 1, treat it like a hazardous area install. Use ATEX certified equipment rated for zone 2, the correct glands and installation methods. And if you're doing this regularly, make sure your Compex is up to date. Option 2, and for most installs, the simple answer: put the isolator outside the zone. Still accessible, still practical, but not sitting where a flammable atmosphere could form. A couple of things catch people out here though. First, the zone isn't just tight to the unit, it extends in front as well. If it's inside the shaded area on the manufacturer drawing, it's still in the zone. Second, boundaries. Install tight to a neighbour's fence and you can push part of the zone into their garden and you don't control what happens next. Today it's empty space, tomorrow it's a hot tub, a shed, or a barbecue area right where you don't want it. Take this example. This heat pump is installed right on the property boundary. Now in this case it's using R32, so the risk is lower, but if this were an R290 unit, we'd have a problem straight away. The isolator is mounted low down, which would put it right inside the potential explosion zone. And it's not just the install itself, part of that zone could extend into the neighbouring driveway. In that situation, you'd need to consider protective measures like a solid impermeable barrier, something like a masonry wall to stop gas spreading. And have a look at this as well. There's an EV charger nearby that could also fall within the zone, so it's not just your isolator you need to think about. It's any electrical equipment in the area: outdoor sockets, garden lighting, EV chargers. Installers who don't normally fit heat pumps might not even realize this risk exists. Now take this one. This heat pump does use R290. There's no external isolator. The manufacturer expects isolation to be inside the property. But look what's been added: an EV charger installed right in what would be the high risk zone. So even if the heat pump installation follows the guidance, other work carried out nearby can reintroduce the risk without anyone realizing. So what does this mean in reality? It means you can't tuck the isolator neatly out of sight behind the heat pump anymore. If it's outside the zone, it's probably going to be loud and proud, above the unit or off to the side, clearly visible on the wall. And let's be honest, nothing screams heat pump install quite like a red and yellow isolator slapped on the brickwork, giving the house that unmistakable factory finish. But, and this is the good third bit, it doesn't actually have to be that way. Instead, you could choose a smart-looking isolator like this one from Scame, sleek design, high performance, and built to withstand whatever the weather decides to throw at it. And here's another little secret, doesn't have to be red and yellow either. And we'll explain why, plus a load of other installer-friendly features in the video on screen now. And while we're talking heat pump headaches, another issue creating confusion for installers is RCDs, and whether you even need to install one at all. Make sure you're subscribed to the channel because that video is dropping very soon.